There was no sudden movement in the heavens above, yet something was moving faster than anything from our solar system. 3I Atlas. It tore through the inner planets at 130,000 kilometers per hour, its coma glowing almost entirely with carbon dioxide. Scientists watched its tail shifting unpredictably in disbelief, wondering what could drive such strange behaviour. Whatever it isn't behaving like anything we've ever seen. On July 1st, 2025, a survey telescope in Chile detected a faint object moving against the background of stars. At first, astronomers treated it like any other small body in the sky. But as they calculated its orbit, the numbers didn't fit known cometary patterns. Its trajectory was hyperbolic, moving too fast to be bound to the sun. It became clear that this object had arrived from beyond our solar system. With an eccentricity of roughly 6.14, 3I Atlas would not return, joining the ranks of only the third confirmed interstellar visitor to be observed. The first was 1I Oumuamua in 2017, the second 2I Borisov in 2019, and now 3I Atlas arrived in 2025. From a distance, it resembled a comet. Observations revealed a fuzzy coma and a developing tail. Gas and dust streamed off its surface as it approached the inner solar system, behaviour typical of small icy bodies heated by the sun. But as instruments probed more closely, the object began to behave in ways that challenged standard cometary models. Infrared observations from the James Webb Space Telescope in August 2025 highlighted a coma unusually rich in carbon dioxide. Water vapour was present, but in far smaller quantities than expected for a comet at that distance from the sun. Carbon monoxide, carbonyl sulfide, and other volatiles were detected as well, but the CO2 to H2O ratio was among the highest ever recorded in a comet. This composition suggested that 3I Atlas had an origin very different from comets formed in the solar system. Scientists theorized it may have spent millions or billions of years drifting through interstellar space, with cosmic rays gradually altering its surface chemistry and creating a crust enriched in carbon dioxide. Polarimetric studies revealed additional anomalies. By analyzing how sunlight scattered off its dust, astronomers detected an extreme negative polarization branch at small phase angles. The minimum reached roughly -2.7% at a phase angle of 7 degrees, with an inversion angle around 17 degrees. Such readings were unmatched. The dust or gas particles producing this effect appeared fundamentally different from those found in any previously studied comet or asteroid. They may be finer, layered, shaped unusually, or composed of entirely unfamiliar material. Estimates of the nucleus size added to the uncertainty. Observers placed its radius somewhere between 0.16 kilometers and 2.8 kilometers, depending on assumptions about sublimation processes and material properties. Even the hyperbolic orbit, which confirmed its interstellar origin, revealed subtle irregularities. Small accelerations, likely from jets of outgassing, altered its path slightly, but in ways inconsistent with typical cometary recoil. The accelerations varied over time, hinting that the jets might fire sporadically or originate from uneven distributions of volatiles within the nucleus. As 3I Atlas approached perihelion around October 29th, 2025, at approximately 1.357 astronomical units from the Sun, its activity became even more peculiar. The coma shifted shape unpredictably, and the tail frequently failed to follow the expected trajectory of standard cometary dynamics. Gas and dust flowed both toward and away from the Sun, creating asymmetries not typically observed in comets at similar distances. These behaviors suggested that the object's internal structure, volatile content, or surface properties differ fundamentally from known solar system comets. Comparing 3I Atlas to the previous interstellar visitors highlights its uniqueness. Oumuamua in 2017 displayed an elongated shape, non-gravitational acceleration, and no obvious coma. Borisov, on the other hand, behaved like a more typical comet, with water-driven activity and a recognizable nucleus. 3I Atlas shares some traits with both, but diverges in several ways, from its CO2-rich composition to its unusual dust-scattering properties and irregular activity. Scientists continue to consider whether the object's properties could hint at anything artificial. No evidence supports this idea. Observations show no metallic structures, no engineered surfaces, no radio emissions, and no propulsion. Claims about artificial origins require extraordinary evidence, which currently does not exist. Nevertheless, the object's peculiarities fuel speculation about its origin. Its chemical profile, dust properties, and activity patterns all suggest a formation history unlike anything seen in the solar system. It could have formed in a distant planetary disk around another star, with conditions vastly different from those in our own planetary system. Interstellar comets like 3I Atlas provide invaluable insight into planetary systems beyond our own. Their composition, structure, and activity offer a glimpse into processes that occur under different radiation levels, temperatures, and chemical environments. By studying these bodies, astronomers can gain an understanding of how volatile-rich materials form under conditions far removed from the Sun, how cosmic rays alter surfaces over long timescales, and how dust and ice evolve in interstellar space. Some of the object's anomalies may still be explained by natural processes. Its high CO2 content, irregular outgassing, and unusual polarization could all result from a combination of interstellar travel, surface processing by cosmic rays, and heterogeneous material distribution. Yet, the combination of all these factors makes 3I Atlas unique. Its irregular behaviour, unexpected chemical composition, and complex dust environment challenge assumptions that astronomers rely on to classify and understand cometary bodies. The observational campaigns tracking 3I Atlas involved multiple instruments and collaborations. Ground-based telescopes in Chile, Hawaii, and Europe contributed optical imaging, while the Hubble Space Telescope and JWST provided high-resolution observations and infrared spectra. Continuous monitoring captured subtle changes in brightness, dust morphology, and outgassing rates, allowing scientists to reconstruct a detailed timeline of the comet's approach, perihelion passage, and subsequent departure from the inner solar system. Even the smallest readings from 3I Atlas surprised astronomers. It shot through the solar system so fast it followed a hyperbolic path that proved it came from beyond the Sun's gravity well. Its nucleus likely spans from roughly 440 meters to up to 5.6 kilometers. A wide estimate, but at any size, it's big enough to matter. Then came the real oddities. Telescope data from the James Webb Space Telescope, JWST, showed a coma, the familiar gas and dust halo that comets have, but the makeup was unusual. The gas cloud came overwhelmingly from carbon dioxide, CO2, not the water vapor we normally expect. CO2 dominated, with water and other volatiles showing up only faintly. That ratio, CO2 to H2O, ranks among the highest ever observed in any comet. Then there's how 3I Atlas interacts with light. Polyometric observations, measurements of how sunlight scatters off its dust, revealed a deep and narrow negative polarization branch, with values and angles never before seen in any comet or asteroid. That suggests the dust or ice grains swirling around it aren't just weird, they may be fundamentally different in structure or composition than anything we know. Combine those chemical and optical anomalies with its weird hyperfast orbit, and you get an object that doesn't sit neatly into the comet category. That raises uncomfortable questions. Could 3I Atlas be more than a comet? Could it be some kind of artificial object? Perhaps even a probe, or a vessel carrying alien life or relics? There's no proof of metal surfaces, propulsion, or radio signals. No smoking gun, but the behaviour, CO2-dominated outgassing, strange dust properties, hyperbolic, non-returning trajectory doesn't neatly match our comet playbook either. That unpredictability matters. Comets in our solar system behave roughly the same. As they warm, water sublimates, gas and dust flow out, and comas and tails form in predictable ways. But 3I Atlas breaks those patterns. Its motion appears too fast, too linear. Its chemistry feels alien. Its dust scattering defies models. If it's natural, 3I Atlas could come from a distant planetary system very different from ours, perhaps with volatile chemistry shaped by extreme conditions, cosmic ray bombardment, or formation near a CO2 ice line. Such a history might explain its strange behaviour. On the other hand, if we try to treat it like an engineered object, a probe, we run into a wall. No evidence. But the lack of evidence isn't proof of absence when every assumption about composition and behaviour is challenged. 3i Atlas shows us how fragile our classifications are. Comet, asteroid, interstellar object, probe. Each label carries assumptions. This object refuses to fit, and that alone makes it terrifying, not in the sense of danger, but in the sense that it reminds us how little we understand. We have one chance to observe it closely before it disappears forever. Every bit of data counts. Each chemical signature, each wobble in motion, each dust grain measurement could tip the scale toward natural or something else. Because right now, 3i Atlas doesn't behave like a comet. And if the universe ever sends another visitor from the stars, we may need to ask ourselves, are we ready to accept what we can't explain? 3i Atlas is leaving while its path shifts, leaving behind questions with no answers. It was never ordinary. Every observation reminds us how little we understand and how fragile our assumptions are. The universe doesn't explain itself, and 3i Atlas proved that. Stay alert for the next revelation. Subscribe, follow the latest data drops, and keep watching, because the next interstellar visitor could change everything we think we know.